All right, so today we're going to take a deep dive right into the heart of HTTP semantics.
Deep dive is right.
Yeah. And we're going to be pulling some really crucial insights straight from RFC 91OD.
Okay.
Which, for our listeners who might not be familiar, this is the document.
Right, the spec.
The spec that outlines exactly how HTTP works.
Exactly.
And I know semantics,
Yeah.
doesn't always sound the most exciting, but it's the foundation.
It is.
It really is.
Yeah. It is the foundation of the web as we know it.
Yeah. And whether you're building web apps or you're troubleshooting, bugs.
Right.
Or if you just want to peek behind the curtain to see how this magic works.
Right.
This is kind of your backstage pass.
Exactly. Yeah, it's like that sort of behind the scenes understanding how the sausage is made.
Yeah.
Kind of thing.
Exactly.
Yeah.
So let's start, I guess.
Yeah.
With the very basics.
Yeah.
What is HTTP?
So HTTP stands for Hypertext Transfer Protocol. And as you mentioned, it's really the language that your web browser uses to communicate with web servers all over the world. And that's how you're able to get websites, images, videos, really anything that you're seeing in your web browser. All of that stuff comes through HTTP.
So every time, I'm browsing the webs, my browser's having a conversation with the server.
You got it.
Using HTTP.
That's exactly right.
And RFC 9110, that's the rule book for that conversation?
Precisely.
Okay.
Okay.
So in this document, this RFC 9110, it defines HTTP as, and this is a mouthful,
Okay.
a stateless application-level request/response protocol.
Right.
Now, each of those terms I feel like is important.
It is, yeah.
Let's break it down a little bit.
Yeah.
So what does it mean for HTTP to be stateless?
So stateless in the context of HTTP means that every single request that you make is an independent request. So the server that's receiving that request doesn't really have any memory of your previous requests. So it's kind of like, every time you go up to order something at a restaurant, the waiter's not going to remember what you had last time.
Right. Unless they're really good or they've seen you, every day.
Or you're a regular.
Yeah. So if I go to a website multiple times, the server's not going to be like, oh, hey.
That's right.
It's you again.
Yeah, you're back.
Okay.
Hi.
Okay, interesting. So it's kind of like every time you visit a website, it's like starting a new conversation.
Exactly.
Okay. And I would imagine that can pose some interesting challenges.
It does.
As you're building websites, how do you
Right.
How do you handle things like sessions? Or,
Yeah. So if you want to maintain some sort of memory between requests, then you have to build that in yourself.
Right.
Using cookies, server-side sessions, things like that.
Yeah. Interesting. So statelessness, kind of a core characteristic.
Yeah.
But it creates these kind of unique challenges.
That's right.
Okay.
Yeah.
All right. So we talked about statelessness. What about application level? What does that mean in this context?
So what that means is that HTTP operates at the application layer of the Internet Protocol Suite, which is a kind of a fancy way of saying that it sits at a higher level than, let's say, TCP or IP,
Right.
the protocols that actually move bits and bytes around.
Okay. So it's not so much concerned with how the data is getting transmitted across the network.
Exactly.
It's more concerned with
what the applications are going to do with that data.
with the content of
Yeah, the meaning of that data.
Gotcha. So it's more about the message itself, not the delivery truck.
Exactly.
Okay. All right. And then the last piece of this, mouthful,
Right.
is request/response. That one seems, I think, fairly self-explanatory.
Oh, that one's a little more intuitive, right?
Yeah. What is that?
Yeah, so HTTP communication really is all about the client, your web browser, making requests to servers and servers sending back responses. So it's this constant sort of back and forth.
A conversation.
Yeah, digital conversation.
Exactly.
Okay, all right. So we've got this conversational flow. I'm starting to get a picture of it. But how does HTTP actually locate things on the internet?
Right.
It's a vast, vast space.
It is.
How does it actually find anything?
Right. So that's where URIs and URLs come in. So starting with URI, which stands for Uniform Resource Identifier, that's really like the address for anything on the web. Yeah. So if it's a web page or an image or a document, anything on the web, it has a URI that uniquely identifies that particular resource.
Okay, so it's like a digital address label.
That's exactly right. Yeah.
Okay.
Yeah.
What about URLs then?
So a URL, or Uniform Resource Locator, is a type of URI. It not only tells you the address, but it also tells you how to access that resource. So it includes the protocol, like HTTP or HTTPS, and the location of the server, like the domain name. So it's like if the URI is just the address, the URL is like
Yeah,
The full directions?
It's the directions of how to get to that address.
Yeah. Okay, so it includes like what road to take, what mode of transportation, all that good stuff.
Precisely.
Okay. Can we break down a URL? Like, what are the different parts?
Absolutely. Yeah. So if we take a really simple example like https://www.example.com page1.search query, that's a URL.
Okay. So we've got, as a budding programmer, I see HTTPS.
Right.
I see www.
Yeah. So that HTTPS part, that's the protocol. So that tells the browser to use the secure version of HTTP.
Okay.
The www.example.com, that's the domain name, that identifies the specific server that hosts the website. Then you've got page one, that's what we call the path, that specifies where that resource is located on that server. And then finally, you have insert search query. Those are query parameters. They provide kind of extra instructions or filters for the request.
Okay, so like each part of the URL kind of builds on the previous ones, like getting more and more specific.
Exactly, yeah.
Okay. All right, so that's our URL. It's the where of the conversation.
Right.
But how do we tell the server, like, what we want?
Yeah, those are the verbs of HTTP. They tell the server what you want to do.
Okay, so it's like...
The action.
Yeah, like, give me the rundown of some of the most essential HTTP methods.
So probably the one that you're most familiar with, even if you don't realize it, is GET. And GET is what your browser uses every time you load a web page.
Okay, so if I'm just scrolling through my favorite blog, every time I load a new page...
You got it. That's a GET request.
Okay. And when you're sending information, like when you submit a form.
Exactly. That's where you would use a POST request.
Mm-hmm.
So GET is for retrieving information. POST is for sending information.
Okay. GET, POST. What else?
We also have PUT, which is used to completely replace a resource on the server.
Right.
And then we have delete, which is, as the name suggests, for deleting a resource.
Okay, so GET, POST, PUT, delete. Those are some of the
No, those are sort of the core ones.
the core verbs of HTTP.
Exactly.
Okay. All right, so we've got the ways to ask.
Right.
But how do we know if the server's listening? Or if it understood what we said?
That's where HTTP status codes come in.
Okay.
So those are 3-digit codes that the server sends back to tell you how your request went.
Okay, so it's like...
Little report cards.
Yeah, a report card.
Yeah.
Okay, all right. What are some of the status codes that we should be on the lookout for?
Well, probably the most famous one is 200. That means, okay, everything went well. You got what you asked for.
200. Okay. I like that one. That's a good one to get.
That's the one you want.
All right. What are some of the other ones?
The one that maybe everyone's familiar with, whether they realize it or not, is 404.
Right. 404.
Not found, which means the server couldn't find what you're looking for.
The internet equivalent of a dead end.
Exactly, yeah.
Okay. What about, what if something goes wrong on the server side?
Yeah, that's a 500 error.
500. Oh.
Okay, internal server error.
Okay. So that's not our fault.
Exactly, that's on their end.
It's something we got to let them know. Hey,
Yeah,
something's broken.
right.
Okay.
Yeah.
All right. Are there any others that are kind of good to know?
Yeah, there are a couple of redirection ones that are good to be aware of, 301 and 302. So those tell you that the resource you're looking for has moved. And they'll usually tell you where it's moved to.
Okay, so it's like a change of address.
Exactly.
Okay.
Yeah.
All right. So we've got our methods for making requests. We've got our codes for understanding responses.
Right.
Is there anything else that kind of adds some more nuance to these HTTP conversations?
Absolutely. We have HTTP headers, which are kind of like extra instructions or labels attached to requests and responses.
Okay.
They provide additional information about the message.
So it's like they're adding some context
Exactly.
to the conversation.
Yeah.
Okay, what kind of information do they carry?
So one really important header is content type, which tells the client what kind of data is being sent, whether it's text, an image, a video, or something else.
Okay, so it's like labeling the package so you know what you're getting.
That's exactly right, yeah.
Okay.
We also have content length, which tells you how big the data is.
Okay.
And then we have user agent, which tells the server what client is making the request.
So it's like the browser introducing itself.
Exactly, yeah.
Okay, all right. Headers. That makes a lot of sense. Now, before we move on, I want to talk about something that is probably near and dear to everybody listening, and that is speed.
Speed.
How does HTTP make sure that, browsing the web isn't as slow as it was back in the dial-up days?
So one of the key things that HTTP does is something called caching.
Okay.
And caching is basically a way of storing copies of frequently accessed resources so that you don't have to go back to the server every time you need them.
So it's like having your own little local library
That's exactly right.
of web resources.
Okay.
All right, so we've got headers, we've got caching.
Right.
What else is there to know about this inner workings of HTTP?
Well, we can't talk about HTTP without talking about security.
Of course, yeah.
Because we share a lot of sensitive information online.
Yeah.
So understanding how HTTP keeps that information safe is really, really important.
All right, so let's dive into the world of HTTP security.
Yeah.
What are some of the things that are in place to make sure that our online interactions are safe?
So one of the biggest ones, of course, is HTTPS,
Right.
which is the secure version of HTTP.
Okay.
It uses encryption to protect your data as it's traveling between the client and the server. So it's kind of like putting your information in a locked box
Okay.
that only the intended recipient can open.
Okay, so it's kind of like sending secret messages.
Exactly.
Yeah.
But
Sure.
how do you make sure that the server is actually who they say they are, right? So that's where authentication comes in. So servers can actually verify your identity using various methods. You know, the most common one is using a username and password. But there are more sophisticated techniques like using digital certificates.
It's like a digital bouncer at the door,
Exactly.
making sure that only the right people get in.
Precisely.
Okay.
Yeah.
What are some of the other kind of threats or vulnerabilities that we should be aware of?
So one that comes up fairly often is called cross-site request forgery, or CSRF.
Okay. CSRF.
Yeah. And that's basically where an attacker can trick a user into performing an action on a website that they're already logged into without them realizing it.
That sounds pretty sneaky.
It is. It's a very sneaky attack.
How did that work?
Yeah. So imagine you're logged into your bank's website. A CSRF attack could be something like tricking you into clicking a link.
Okay.
That secretly sends a request to your bank to transfer money to the attacker's account
Without you even knowing.
without you even realizing it. Yeah.
Wow, that's kind of scary.
Yeah.
What can we do to protect ourselves from that?
So thankfully, there are a lot of ways to defend against these attacks. Developers can implement what are called security tokens,
Okay.
which basically make it much, much harder to forge those requests. So they act like, unique identifiers that validate each request.
Okay. So it's like a secret handshake.
Exactly, yeah.
All right. So we've got HTTPS, we've got authentication, we've got these measures in place to prevent these sneaky attacks.
Right.
That makes me feel a little bit better.
Yeah, and I think, security is an ongoing battle.
Right.
But understanding the basics is, the first step to making sure that you're building things that are safe and reliable.
Absolutely.
Yeah.
All right. Well, this has been a lot of information.
Yeah, we covered a lot of ground.
We really have. But I feel like we've only just scratched the surface.
That's right. Welcome back to our deep dive into HTTP. Before we move on, I want to just emphasize something we touched on earlier, and that's security. As budding programmers, it's so important to bake security into the applications that we're building.
Absolutely. I mean, security breaches, those can have some pretty devastating consequences.
Yeah.
So how can we make sure that the web applications we're building are as secure as Fort Knox?
So one of the fundamental things is establishing authority, right? So HTTP has this concept of an authoritative response, which basically means that the response has been verified to have come from the correct source. And this helps prevent things like, attackers from impersonating a website and tricking users into thinking that it's a legitimate website.
So it's like checking the sender's ID before opening an email.
Exactly. Yeah. You want to make sure you're not being phished.
Yeah. But how does HTTP actually go about establishing this authority?
So that's where HTTPS comes in. HTTPS uses digital certificates to authenticate the server. So these certificates are kind of like digital passports. They vouch for the server's identity.
So when I see that little padlock icon up in my browser bar,
Exactly.
that means that the website is using HTTPS.
That's right.
And my data is being transmitted securely.
That's exactly right.
Okay, good. But even with HTTPS, we can't just rest on our laurels.
Oh, no. It's an ongoing process.
Yeah, we got to be vigilant, right?
Yeah, you got to stay vigilant.
Okay, so what are some of the other security considerations we should be thinking about?
So one thing to watch out for is what are called command injection attacks. This is where an attacker might try to sneak in some malicious code that could give them access to the server systems. And they do that by exploiting flaws in how the server processes input from the user. So it's kind of like slipping a virus into a seemingly harmless file.
Okay, that's pretty sneaky.
Yeah.
So how can we prevent these command injection attacks from happening?
The key is to never trust user input blindly. You always want to validate and sanitize any data that you receive from the client. Make sure that it conforms to the expected format and doesn't contain any potentially harmful code.
So it's not just about writing code that works. It's also about writing code that's resilient.
Exactly.
Okay. Okay. What else should we be thinking about?
So another potential area of vulnerability lies in how HTTP handles logging.
Okay.
So HTTP logs contain a lot of information about user activity.
Right.
Which can be sensitive, right? So if these logs aren't protected properly, they can be a goldmine for attackers.
So treat those logs like confidential documents.
Exactly.
Keep them under lock and key.
Yeah. You got to be very careful with that. Be mindful of data privacy and implement safeguards.
Yeah, okay.
Now, here's another thing that people often don't think about, and that's validator retention. So HTTP uses these things called validators, like e-tags and last modified headers, to help check if a resource has changed since the last time it was cached. That ensures the client is getting the most up-to-date version.
So it's like a timestamp to make sure everything is fresh.
Yeah, that's a good way to put it. But here's the thing. If those validators are kept around for too long, they could potentially be exploited by attackers.
So it's like holding on to an expired passport.
Yeah.
It might have been valid at one point, but now it's a liability.
Exactly, yeah. So refreshing those validators is a good security practice.
It's like renewing your passport.
Precisely.
Okay. Okay. I'm noticing a theme here. We got to stay vigilant. We got to be proactive about this stuff.
Absolutely, yeah. Security is something you have to consider every step of the way, right? From the initial design all the way through to deployment.
Okay. Okay, great. So we've talked a lot about security, from establishing authority to protecting those sensitive logs to managing those validators. Let's shift gears a little bit and talk about another aspect of web development, and that is efficiency.
Efficiency, yeah.
Got to make sure things run smoothly and swiftly.
Absolutely. And HTTP has some tools to help with that.
Well, you're talking about caching.
Caching, yeah.
We touched on that before in terms of speed.
Right.
But I imagine it plays a pretty big role in efficiency as well.
Oh, absolutely. It's really a cornerstone of web performance. It can drastically reduce the number of requests that have to be sent to the server, which makes websites load faster. It reduces the load on the server.
It's like having that local copy. You don't have to go back to the library every time.
That's exactly right, yeah. But there's another aspect of caching that's especially interesting from a programmer's perspective, and that's conditional requests.
Conditional requests.
Yeah. This is a way for the client to ask the server, hey, has this resource changed since the last time I accessed it?
Okay.
And if it hasn't, the server can just say, nope, you're good. Use the cached version.
So it's like calling the library and saying, hey, has this book been updated?
That's a great analogy.
Yeah. Before I drive all the way over there.
Exactly.
Okay. So how do we make these conditional requests?
So HTTP has a set of conditional request headers that let the client specify the conditions under which it wants to get a response.
Okay, like what? What are some of these headers?
So some key ones are if match, if none match, if modified since, and if unmodified since.
Okay, so each of those headers provides a way for the client to check the status of the resource before it decides whether it needs to download it again.
Exactly, yeah.
Wow. Okay. So can we go through each of those, just kind of see how they work?
Sure, yeah. So let's start with if match. So if match lets the client provide a list of entity tags. Those are also called e-tags.
Right.
For a resource that it already has.
Those e-tags, those are like fingerprints.
That's right.
For a resource.
Exactly, yeah.
Okay.
They identify a specific version.
So with if match, the client's basically saying, hey, if the e-tag of the resource on the server matches one of these that I already have, then send it to me. Otherwise, let me know it's changed.
You got it. That's exactly right. So if the server sees that, yep, I've got a matching e-tag, it knows the client already has the latest version. It doesn't need to send it again.
Okay. That's a good way to save some bandwidth. What about if none match?
So if none match works the opposite way. So the client provides a list of e-tags, and it says, only send me the resource if its e-tag doesn't match any of these.
Okay.
So that's useful if you want to see if a resource has been updated.
Right, because if it matches...
If it matches, you already have it.
You don't need it.
Yeah.
Okay. What about those other two headers, if modified since and if unmodified since?
So those two work in a similar way to if match and if none match, but instead of using e-tags, they use timestamps.
Okay, so the client can basically say, hey, only send me the resource if it's been modified after this date and time.
Exactly, yeah.
Okay.
So if modified since is for things that have been modified after a certain time, and if unmodified since is for things that have been modified before a certain time.
All right, so we've got this whole arsenal of conditional request headers that we can use.
That's right.
To make sure we're only getting the resources we need and we're minimizing those data transfers.
Exactly, yeah. So you can build really efficient applications, especially if you're working with a lot of data.
Yeah, absolutely. Well, this has been pretty eye-opening.
Yeah, we're covering a lot of ground here.
We've gone through security, we've gone through caching and conditional requests. I'm really starting to see how all these pieces fit together.
Yeah, it's all starting to come together, right?
Yeah.
But we're not done yet.
Oh, there's more.
There's more. In the final part of our HTTP journey, we're going to talk about how HTTP handles all the amazing content that makes up the web.
All right. Looking forward to it. All right. So we've journeyed through the inner workings of HTTP, right? We've seen how it handles security, how it keeps things efficient with caching. But for this grand finale, let's talk about how HTTP handles all this, like amazing content that we see on the web.
Yeah, it really is amazing how HTTP can deal with, simple text and high-definition videos, all using the same basic language.
So how does it know what it's dealing with? Like, is it a web page? Is it a song? Is it a 3D model? How does it know?
It uses something called media types. You might also hear them called MIME types, which stands for Multipurpose Internet Mail Extensions.
MIME types. I thought that was just for email.
Yeah, that's a common misunderstanding. They did originate in email, but they've become really important for the web, too. It's how browsers know what to do with the data they receive.
Right, because both email and the web, they deal with all kinds of different content.
Exactly.
Okay, so how do these MIME types work? Give me the rundown.
Think of them like labels that tell the client what kind of data is being sent. They have a type and a subtype, separated by a slash.
So like text plain for plain text, image peg for a JPEG.
Exactly. There are tons of UMI types out there, each one for a specific kind of content. When the server sends data, it includes the MIME type in the header.
Oh, so the content type header, that's like the universal translator. It makes sure the client knows what to do with the data.
That's a great way to put it. And just like languages can have dialects, MIA types can have extra parameters too that give even more info about the content.
Like what?
Well, a common one is charset, which tells you the character encoding used for text. So text TML charset UTF-8 means the web page is encoded with UTF-8.
Okay, so it's like making sure everyone's speaking the same language, so there's no garbled text.
Right. It's all about making sure the content is displayed correctly, no matter what language you speak or what operating system you're using.
Okay, MIME types. Got it. But what about when we need to send really big files, like high-res images or videos? How does HTTP handle that?
Content coding. It lets you change the data before it's sent, usually to compress it or encrypt it.
It's like packing a suitcase efficiently.
Exactly. You can squeeze more in, or you can add a lock for security.
Right.
Popular algorithms for compression are things like gzip and deflate. They make files smaller and faster to transfer.
So compression is like zipping a file.
Exactly.
Yeah.
And for security, HTTP itself doesn't actually do the encryption, but it works with other protocols like TLS or SSL.
Right, that's where HTTPS comes in.
Exactly. When you see that HTTPS in the URL, you know the connection is secure.
Encryption. Super important these days, especially with all the sensitive information flying around online.
Absolutely crucial. A must-have for secure web apps.
Okay, so MIME types tell us what the content is, content coding lets us transform it, and HTTPS keeps it safe. Anything else we need to know about how HTTP handles all this stuff?
One more cool thing is content negotiation. It lets the client tell the server what kind of content it prefers, and the server can try to accommodate those preferences.
So it's like the client can say, hey, I'd really like to see this image in JPEG format.
Exactly. They can use headers like accept encoding, and accept language to say what they prefer.
And the server can then use that info to send the best version of the resource.
Right. It makes the web more accessible and user-friendly, different devices, different preferences, everybody's happy.
Well, I think we've really explored HTTP inside and out today.
We covered a lot, yeah.
From the basics to security to caching to how it handles all this content. This deep dive has been amazing.
It has been. And before we go, I want to leave everyone with one thought. HTTP is always changing, always evolving. New stuff is coming out all the time, so keep learning.
Great advice. And a huge thank you to our expert for guiding us through this. And to our listeners, thanks for joining us. Keep exploring, keep learning, and keep building awesome things on the web.